Chapter 17. The next day, the 7th of May, Smith and Spilett, leaving Neb to prepare the breakfast, climbed the plateau, while Herbert and Pencroff went after a fresh supply of wood. The engineer and the reporter soon arrived at the little beach where the dugong lay stranded. Already flocks of birds had gathered about the carcass, and it was necessary to drive them off with stones, as the engineer wished to preserve the fat for the use of the colony. As to the flesh of the dugong, it would undoubtedly furnish excellent food, as in certain portions of the Malay archipelago it is reserved for the table of the native princes. But it was Neb's affair to look after that. Just now, Cyrus Smith was thinking of other things. The incident of the day before was constantly presenting itself. He wanted to solve the mystery of that unseen combat, and to know what congener of the mastodons or other marine monster had given the dugong this strange wound. He stood upon the border of the lake, looking upon its tranquil surface sparkling under the rays of the rising sun. From the little beach where the dugong lay, the waters deepened slowly towards the center, and the lake might be likened to a large basin, filled by the supply from Red Creek. "Well, Cyrus," questioned the reporter, "I don't see anything suspicious in this." "No, my dear fellow, and I am at a loss how to explain yesterday's affair. The wound on this beast is strange enough, and I can't understand how Top could have been thrown out of the water in that way. One would suppose that it had been done by a strong arm, and that that same arm, wielding a poignard, had given the dugong his death wound." "It would seem so," answered the engineer, who had become thoughtful. "There is something here which I cannot understand. But neither can we explain how I myself was saved, how I was snatched from the waves and borne to the downs. Therefore, I am sure there is some mystery which we will some day discover. In the meantime, let us take care not to discuss these singular incidents before our companions, but keep our thoughts for each other, and continue our work." It will be remembered that Smith had not yet discovered what became of the surplus water of the lake, and as there was no indication of its ever overflowing, an outlet must exist somewhere. He was surprised, therefore, on noticing a slight current just at this place. Throwing in some leaves and bits of wood, and observing their drift, he followed this current, which brought him to the southern end of the lake. Here he detected a slight depression in the waters, as if they were suddenly lost in some opening below. Smith listened, placing his ear to the surface of the lake, and distinctly heard the sound of a subterranean fall. "It is there," said he, rising, "there that the water is discharged, there, doubtless, through a passage in the massive granite that it goes to join the sea, through cavities which we will be able to utilize to our profit. Well, I will find out." The engineer cut a long branch, stripped off its leaves, and, plunging it down at the angle of the two banks, he found that there was a large open hole a foot below the surface. This was the long-sought-for outlet, and such was the force of the current that the branch was snatched from his hands and disappeared. "There can be no doubt of it now," repeated the engineer. "It is the mouth of the outlet, and I am going to work to uncover it." "How?" inquired Spilett. "By lowering the lake 3 feet. "And how will you do that?" "By opening another vent larger than this." "Whereabouts, Cyrus?" "Where the bank is nearest the coast." "But it is a granite wall," exclaimed Spilett. "Very well," replied Smith. "I will blow up the wall, and the waters, escaping, will subside so as to discover the orifice." "And will make a waterfall at the cliff," added the reporter. "A fall that we will make use of," answered Cyrus. "Come, come." The engineer hurried off his companion, whose confidence in Smith was such that he doubted not the success of the undertaking. And yet, this wall of granite, how would they begin? How, without powder, with but imperfect tools, could they blast the rock? Had not the engineer undertaken a work beyond his skill to accomplish? When Smith and the reporter re-entered the Chimneys, they found Herbert and Pencroff occupied in unloading their raft. "The woodchoppers have finished, sir," said the sailor, laughing, "and when you want masons." "Not masons, but chemists," interrupted the engineer. "Yes," added Spilett, "we are going to blow up the island." "Blow up the island?" cried the sailor. "A part of it, at least," answered the reporter. "Listen to me, my friends," said the engineer, who thereupon made known the result of his observations. His theory was, that a cavity, more or less considerable, existed in the mass of granite which upheld Prospect Plateau, and he undertook to penetrate to it. To do this, it was first necessary to free the present opening, in other words to lower the level of the lake by giving the water a larger issue. To do this they must manufacture an explosive with which to make a drain in another part of the bank. It was this Smith was going to attempt to do, with the minerals nature had placed at his disposal. All entered into the proposal with enthusiasm. Neb and Pencroff were at once detailed to extract the fat from the dugong and to preserve the flesh for food, and soon after their departure the others, carrying the hurdle, went up the shore to the vein of coal, where were to be found the schistous pyrites of which Smith had procured a specimen. The whole day was employed in bringing a quantity of these pyrites to the Chimneys, and by evening they had several tons. On the next day, the 8th of May, the engineer began his manipulations. The schistous pyrites were principally composed of carbon, of silica, of alumina, and sulfuret of iron. These were in excess. It was necessary to separate the sulfuret and change it into sulfate by the quickest means. The sulfate obtained, they would extract the sulfuric acid, which was what they wanted. Sulfuric acid is one of the agents in most general use, and the industrial importance of a nation can be measured by its consumption. In the future this acid would be of use to the colonists in making candles, tanning skins, etc., but at present the engineer reserved it for another purpose. Smith chose, behind the Chimneys, a place upon which the earth was carefully leveled. On this he made a pile of branches and cut wood, on which were placed pieces of schistous pyrites leaning against each other, and then all was covered over with a thin layer of pyrites previously reduced to the size of nuts. This done, they set the wood on fire, which in turn inflamed the schist, as it contained carbon and sulfur. Then new layers of pyrites were arranged so as to form an immense heap, surrounded with earth and grass, with air holes left here and there, just as is done in reducing a pile of wood to charcoal. Then they left the transformation to complete itself. It would take 10 or 12 days for the sulfuret of iron and the alumina to change into sulfates, which substances were equally soluble. The others, silica, burnt carbon, and cinders, were not so. While this chemical process was accomplishing itself, Smith employed his companions upon other branches of the work, which they undertook with the utmost zeal. Neb and Pencroff had taken the fat from the dugong, which had been placed in large earthen jars. It was necessary to separate the glycerin from this fat by saponifying it. It was sufficient, in order to do this, to treat it with chalk or soda. Chalk was not wanting, but by this treatment the soap would be calcareous and useless, while by using soda, a soluble soap, which could be employed for domestic purposes, would be the result. Cyrus Smith, being a practical man, preferred to try to get the soda. Was this difficult? No, since many kinds of marine plants abounded on the shore, and all those fucaceae which form wrack. They therefore gathered a great quantity of these seaweed, which were first dried, and, afterwards, burnt in trenches in the open air. The combustion of these plants was continued for many days, so that the heat penetrated throughout, and the result was the grayish compact mass, long known as natural soda. This accomplished, the engineer treated the fat with the soda, which gave both a soluble soap and the neutral substance, glycerin. But this was not all. Smith wanted, in view of his future operations, another substance, nitrate of potash, better known as saltpeter. He could make this by treating carbonate of potash, which is easily extracted from vegetable ashes, with nitric acid. But this acid, which was precisely what he wanted in order to complete his undertaking successfully, he did not have. Fortunately, In this emergency, nature furnished him with saltpeter, without any labor other than picking it up. Herbert had found a vein of this mineral at the foot of Mount Franklin, and all they had to do was to purify the salt. These different undertakings, which occupied 8 days, were finished before the sulfate of iron was ready. During the interval the colonists made some refractory pottery in plastic clay, and constructed a brick furnace of a peculiar shape, in which to distill the sulfate of iron. All was finished on the 18th of May, the very day the chemical work was completed. The result of this latter operation, consisting of a sulfate of iron, sulfate of alumina, silica, and a residue of charcoal and cinders, was placed in a basin full of water. Having stirred up the mixture, they let it settle, and at length poured off a clear liquid holding the sulfates of iron and alumina in solution. Finally, this liquid was partly evaporated, the sulfate of iron crystallized, and the mother water was thrown away. Smith had now a quantity of crystals, from which the sulfuric acid was to be extracted. In commerce this acid is manufactured in large quantities and by elaborate processes. The engineer had no such means at his command, but he knew that in Bohemia an acid known as Nordhausen is made by simpler means, which has, moreover, the advantage of being non-concentrated. For obtaining the acid in this way, all the engineer had to do was to calcinize the crystals in a closed jar in such a manner that the sulfuric acid distilled in vapor, which would in turn produce the acid by condensation. It was for this that the refractory jars and the furnace had been made. The operation was a success, and on the 20th of May, 12 days after having begun, Smith was the possessor of the agent which he expected to use later in different ways. What did he want with it now? Simply to produce nitric acid, which was perfectly easy, since the saltpeter, attacked by the sulfuric acid, would give it by distillation. But how would he use this acid? None of the others knew, as he had spoken no word on the subject. The work approached completion, and one more operation would procure the substance which had required all this labor. The engineer mixed the nitric acid with the glycerin, which latter had been previously concentrated by evaporation in a water bath, and without employing any freezing mixture, obtained many pints of an oily yellow liquid. This last operation Smith had conducted alone, at some distance from the chimneys, as he feared an explosion, and when he returned, with a flagon of this liquid, to his friends, he simply said, "Here is some nitroglycerin." It was, in truth, that terrible product, whose explosive power is, perhaps, 10 times as great as that of gunpowder, and which has caused so many accidents. Although, since means have been found of transforming it into dynamite, that is, of mixing it with clay or sugar or some solid substance sufficiently porous to hold it, the dangerous liquid can be used with more safety. But dynamite was not known when the colonists were at work on Lincoln Island. "And is that stuff going to blow up the rocks?" asked Pencroff, incredulously. "Yes, my friend," answered the engineer, "and it will do all the better since the granite is very hard and will oppose more resistance to the explosion." "And when will we see all this, sir?" "Tomorrow, when we have drilled a hole," answered the engineer. Early the next morning, the 21st of May, the miners betook themselves to a point which formed the east bank of Lake Grant, not more than 500 feet from the coast. At this place the plateau was lower than the lake, which was upheld by the coping of granite. It was plain that could they break this the waters would escape by this vent, and, forming a stream, flow over the inclined surface of the plateau, and be precipitated in a waterfall over the cliff onto the shore. Consequently, there would be a general lowering of the lake, and the orifice of the water would be uncovered. This was to be the result. The coping must be broken. Pencroff, directed by the engineer, attacked its outer facing vigorously. The hole which he made with his pick began under a horizontal edge of the bank, and penetrated obliquely so as to reach a level lower than the lake's surface. Thus the blowing up of the rocks would permit the water to escape freely and consequently lower the lake sufficiently. The work was tedious, as the engineer, wishing to produce a violent shock, had determined to use not less than 2 gallons of nitroglycerin in the operation. But Pencroff and Neb, taking turns at the work, did so well, that by 4 o'clock in the afternoon it was achieved. Now came the question of igniting the explosive. Ordinarily, nitroglycerin is ignited by the explosion of fulminated caps, as, if lighted without percussion, this substance burns and does not explode. Smith could doubtless make a cap. Lacking fulminate, he could easily obtain a substance analogous to guncotton, since he had nitric acid at hand. This substance pressed in a cartridge, and introduced into the nitroglycerin, could be lighted with a slow match, and produce the explosion. But Smith knew that their liquid had the property of exploding under a blow. He determined, therefore, to make use of this property, reserving the other means in case this experiment failed. The blow of a hammer upon some drops of the substance spread on a hard stone suffices to provoke an explosion. But no one could give those blows without being a victim to the operation. Smith's idea was to suspend a heavy mass of iron by means of a vegetable fiber to an upright post, so as to have the iron hang directly over the hole. Another long fiber, previously soaked in sulfur, was to be fastened to the middle of the first and laid along the ground many feet from this excavation. The fire was to be applied to this second fiber. It would burn till it reached the first and set it on fire, then the latter would break and the iron be precipitated upon the nitroglycerin. The apparatus was fixed in place, then the engineer, after having made his companions go away, filled the hole so that the fluid overflowed the opening, and spread some drops underneath the mass of suspended iron. This done, Smith lit the end of the sulfured fiber, and, leaving the place, returned with his companions to the chimneys. 25 minutes after a tremendous explosion was heard. It seemed as if the whole island trembled to its base. A volley of stones rose into the air as if they had been vomited from a volcano. The concussion was such that it shook the chimneys. The colonists, though 2 miles away, were thrown to the ground. Rising again, they clambered up to the plateau and hurried towards the place. A large opening had been torn in the granite coping. A rapid stream of water escaped through it, leaping and foaming across the plateau, and, reaching the brink, fell a distance of 300 feet to the shore below.